We're going to cover a few topics today. The first one being defining what a linear equation in one variable is. If you want to take a picture of this screen, or if you want a screenshot from your book, it's page 82 in your book. Essentially, there's several characteristics that you need to look for when we're talking about a linear equation in one variable. One, obviously, there's only one variable. That's the first thing. Okay. Secondly, it's a first degree equation, meaning the highest power on the variable is going to be 1. So in all of these problems, x for the linear equations, x is only ever to the first power. Okay, you can have a constant added or subtracted. And so on the left here, these are all examples of linear equations in one variable. There's only one x. It's always to the first power. Some things that you see on the other side that aren't, x is raised 2 powers other than 1, so it's not first degree. When you have an x on the bottom, it really means x to the negative 1. So then again, it's not raised to the first power. This one has 2 variables. Okay, and this is not even an equation. This is just an expression. There's no equal sign. Okay, and one of the things that you're going to have to do in your homework today is identify which equations are linear equations in one variable and which ones aren't, and then be able to say why. So everything in these parentheses over here are explanations as to why these are not linear equations in one variable. Just as a point of reference, when we talk about a linear equation, what's the graph going to be?
A straight line.
A straight line. Okay, a straight line. Okay, so that's important. All right. That's one part of it. Now, we're really talking about solving equations today. Okay, and solving equations in one variable, and you by now are probably really good at this. So we'll review a couple problems and just make sure that we're in good shape with these. Okay, so we're going to do some examples. So here's the first example. 5 times the quantity v minus 4 minus 2 equals 2 times the quantity v plus 7 minus 3. Please solve that. Alright, who's got an answer for me? Austin, what do you got? 3. Anybody have a different answer than 3? How many of you have 3? Raise your hand. Okay. Let's take a look at what we need to do here. So, my first move should have been to distribute and to distribute. Okay. So I have 5v minus 20 minus 2 equals 2v plus 14 minus 3. Now you want to simplify as much as you can on each side first. So I have like terms here and I have like terms there. So I have 5v minus 22 equals 2v plus 11. So now you have a decision to make, right? V's on one side, constants on the other side. Which side do you want to put the V's on, the left or the right? Left side. So let's move 2v by subtracting. And then we're going to add 22 to move it to the other side. 3v equals 33. What's v equal? 11. Okay. How many of you have that? Good. That is the correct answer. So how'd you get 3?
I had 3v and
I literally have 3v equals 33 and I put v equals 3.
Okay. So you just messed up. Alright. Any questions on this? Pretty standard stuff here. Okay. Let's look at a little more complicated one. And then we'll talk about strategy here in a second. What makes this problem more complicated? All the fractions. Now, I know, and I feel the same way, if I can get rid of fractions, I want to do that. So, our strategy here is going to be, do you remember what the strategy is to get rid of the fractions?
multiply by the denominator.
Multiply by the common denominator, that is correct. In this case, what is the lowest common denominator?
12.
Agree? 12. So now what you want to do is you're going to multiply every single thing by 12. The whole thing by 12, and the fraction should go away. So on this first one, the 12 cancels with the 2, which leaves me with a 6. and that has to be multiplied by that y plus 5. The 12 cancels with the 4, leaves me with the 3. Notice the minus stays there, that was there. Okay, and then I have y minus 2. And then the 12 cancels with the 3, so there's a 4. And don't forget to multiply that 12 by 1. Okay, you still have to do that as well. So you have to multiply each term by that common denominator. And that should clear our fractions, which it did. Okay, so go ahead and finish this problem now. Anybody else got negative 4? What do you got? Negative 5? You got 7? What do you got? How many have negative 4? How many have something different than negative 4? Alright, let's check and see. So when I distribute, I get 6y plus 30 minus 3y plus 6 equals 4y plus 28 plus 12. So this gives me 3y plus 36 equals 4y plus 40. Subtract the 3y, subtract the 40. Y does equal negative 4. Very good. One thing I want to point out, so I moved the variables to the right so that it would keep my y positive. So that became a positive y. Let's say you moved to the other side, you would have gotten negative y equals 4 to begin with. So if you would have moved to the other side, you would have had this as one of your lines. Take it another step, because I don't care what negative y is, we care what y is. So then you just flip both sides and you'll get the right answer. Okay? This strategy of clearing the denominator we're going to utilize more on Tuesday when we have more rational type equations with algebraic expressions in denominators instead. So that'll get a little trickier, but what we just did in R6 will help us with that. Any questions before we move on to the next part? Okay. The next part, there's some terminology in this section that I want to make sure that we go over and understand. And we're talking about conditional equations, identities, and contradictions. Okay, and we have to be able to identify what type of equation, we have, and what each of these three terms means. So I'm going to give you each of those definitions, and then we'll look at some examples, okay? And then you'll have the rest of the time to be able to get this homework done. So conditional equations are true for only some value, I should say some values, and false for others. So let's fix that. Sometimes it is just one value though, okay? Conditional equations are true for some values and false for others. So for example, on the last equation, we got y equals negative 4. So it's true when y equals negative 4, the equation will be true. If y equals anything else but negative 4, I will get a false equation, okay? The identity is true for every value. That's an all real numbers solution. Okay. Identities are true for all values. So what do you think contradictions are?
Things that go against.
Say again? No values will work. Okay, they're true for no values. So contradictions are false for all values, or true for none. Okay. So these are the two unique cases where you'll get all real numbers as a solution, or you'll get no solution, or no real numbers. Okay. Those are the three different types of equations that we could deal with. There's a solution for some values, there's a solution for all values, and there's no solution. Okay. So on this next page, if you want to take a picture of the next page, you can, because I put an example of each on the screen so you can kind of see what you're looking at. Because in your homework, there's problems where it says identify which type of equation it is and then solve it. So you'll have to identify them first. So this is on page 85 and 86, so it's split between two pages. Okay. So a contradiction, again, this is the empty set is a solution. If you want to write no solution, that's totally fine too. Okay, the identity, and notice here, as you go through and solve, here's what's going to happen on these two. On these two types of equations, the variables will cancel out. They cancel it out here, they cancel it out here. The difference is, when I simplify as far as I can for a contradiction, I get a false statement. -3 is clearly not equal to. So again, when the variables cancel out and I get a false equation, -3 does not equal -4, then I know it's a contradiction. Okay? And so it's an empty set or no solution.
So you can only, like, identify which one it is after.
Correct. Once you know how many solutions there are, then you know which type of equation it is. Okay? So an identity, when the variables cancel, then I get a true. So it means it's true for every x value. So this one's an identity because I get a true sentence. All real numbers is my solution. And then for a conditional, I just get a solution. The variables don't cancel out. I could get, in the case of a linear equation, there's only ever going to be one solution at max, or you have one of these two situations, okay? If it was a quadratic, you know, where the degree 2, we could have 2 solutions. Or if it's a cubic, we could have 3 solutions. But for a linear equation, we can only get one solution that's not one of these situations, okay? Questions on any of that?